Okay, good morning. Several of you have problems with the homework. Can you give me the problem?
It's my homework.
Yeah, we discussed a little bit before you submit. So, who has the problem?
Problem number 3.
Number 3. Number 3, we want to convolute two signals. First one is xt equals e to the 2t u negative t, and the second one is u to the u t minus 3. We are going to use a diagram. The first one, we need to plot both signals. The first one, we plot x tau. You just think this t is the tau, same thing. E to the 2t times this one. This one is a unit step, but to the left. So just from here all the way to this one. And this one, et is the exponential. So when t equals to 0, that equals 1. So that is 1 here. And when t equals 2, that will be t squared, which equals maybe 10. So it's like this. And all other part will be, when t goes to infinity, negative infinity, that will be equal to 0. So the waveform look like this. But e negative t, u negative t only takes the left half plane. So that means this part will be gone. We only have this one. After this is one. So that is the x tau. Any questions on this? So good. This signal is x tau. E to the 2t is supposed to be like this all the way to the right, but we only pick the left-hand side. Right? H tau is ut step right-hand side, so this is 3, so that is h tau. So you just draw like this, h tau. But we want to inverse this, so h next tau, then this one will be from negative 3, then all the way to the left, like this. So this one will become.
Why'd you turn it to the negative? Why'd you change it to the negative?
Because this one, like this, you need to flip. H tau is start from 3 to the right. And this one need H next tau will flip to the left. So like that. Any questions on this? You need to be very clear on every step, because you need to do this by yourself later time. All other questions. So is this good? We flip only, that means we shift nothing. That means this one looks like there's 0 here. And later time we are going to shift this one for different t. For example, t equals 1. So for tau 1 minus tau, it will shift this figure to the right by 1 time. But if without shifting, that means the shift is only 0. So that's why I put 0 here. The next step is we need to multiply by these two signals. Then we do the integration. This one is when t equal to 0. Just like this. So we multiply this one with this. This one, the amplitude equals 1. So they multiply this with this, where we only pick this part. So this one will be up to this negative 3 to here. And multiply this, so we only get this part. So this, the yt, which equals 0 here, will be equal to the integration of this signal multiplied by this But this one is 1, this one here, so that is e to the 2 tau and d tau. From somewhere, from a definitely negative infinity, because all the way to the left, and to this point, to the t. Right? Now the t here equals 0. So for t equals 0, it's like this. If t, you think about this, if t equals to negative 1, and the key for here is to determine the limit, right? That is very important. So if t equals negative 1, that means we need to shift this one to the left by 1 time, like this. So this one here will be t equals negative 1. Corresponding to this is t equal to 0. Now this one multiplied this is still the same thing. So still the integration is from negative infinity to this point. So for t negative 1, still this. So I can write t less than or equal to 0. So because they are the same thing. Now we consider even more. How about if t equal to 1? T equal to 1 means we shift this here all the way to this one. So this one corresponding to t equal to 1. So this one will be negative 2 here. You multiply this, well, that's still the same signal. Still integration from negative infinity to here. So that means when t equal to 1, okay, that's still good. So we can change this one to 1. Still the same thing. We can just combine everything together. How about 2? How about when t equals 3? This point corresponding to t equals 3. So this one here, they are still the same. So this one all the way to less than 3. Now we get all these times, we get one representation. So if t is less than 3, no matter negative or anything, we can use the same integration. Yes?
So where does t equal 0?
T equals 0. We get, remember in the definition, yt equals ht time convolute with xt. Xt. What is the definition? That can go us from negative infinity to here, and x tau times ht minus tau, d tau.
Yeah, I understand that, but on here you have right next to the negative 3, t equals 0.
Yeah.
Is the x-axis not your time axis?
This one is the tau. All these are tau. Look at this one. All these are tau. The t is a fixed number. For example, I ask you, what is the output when t equals 10? So you just shift this one to the right by 10. That's it. So t here, you know the t. But the tau is the integration variable. Does it make sense? So for example, okay, you already know this, right? Now, for example, if I ask you what is y10? Ask this one. What is the output when t equals 10? How are we going to do this? This x tau is this. That is x tau. Then h, that is connected 3. This is tau. All these x's are tau. So this corresponding to t equal to 0. Is this clear? You need to be clear on this point. If you just flip, do not shift, that corresponds to t equal to 0. Why? Because this one is h negative tau. You flip. Minus 0, that means I can put 0 at before, right? At here. And recall in the formula. The formula is x tau times ht minus tau. D tau. What does that mean? That means the t equal to 0. Right? So that means if we only flip without shifting yet, you multiply, you do the integration, that corresponding to the output when t equals to 0. If I ask you what is the output when t equals 10, then you flip, you need to shift this one to the right by 10 seconds. Right? So 0, this is 0, right? Okay? 1 second, you're going to get at this point. 2 seconds, 3 seconds, it will be at this point. you shift this one to the right. Okay? So 10 seconds, it will be like at this point, so that will be 7. Does this make sense?
Yes.
Okay, so this one is H10 minus tau. Okay? You flip, you shift to the right by 10 times, this gives us H10 tau. Okay? Then in the formula, if you said x tau times H10 minus tau d tau, you do the integration, that gives us what? Give us y10. Right? So that means the time is fixed. We know that. I ask you the output when t equals 10, then you know 10. I ask you the output when t equals 9, then you know 9. So this one gives us 10. So you just multiply these two signals, do the integration for all tau, you get the output at the single time, which is 10 here. The integration result is for only one time. Is the output for only one time. Okay? Further questions on this?
Good.
If you don't know how to do this, ask questions right now. Otherwise, come back next semester. Alright? So you need to know this. Any questions? So if we only flip, it will be here, this blue line, right? We do not shift yet. That means this corresponds to t equal to 0. Right? So for when t equal to 0, you just this one multiply this, give us this part. Then you do the integration from negative this to where? To negative 3, right? To negative 3, then that gives us the output when t equal to 0. Let me write more details. Okay? So when t equal to 0, so y0 will be equal to e to the 2 tau d tau from negative infinity to where? To negative 3, right? Make sense? Okay. So now when t equal to 1, okay, this one will be output when t equal to 1. So this one will be equal to the same thing here, d tau, and the same thing here. Where is this? What is this? Negative 2. How did you get negative 2? It's a negative 3 shift to the right by 1. Right? So that is like negative 3 to the right by 1. So you plus 1. That's how you get this, right? How about when t equals 2? The output when t equals 2 equals same thing here. This one is negative 1. How do you get negative 1? Use negative 3 plus that 2. Right? Shift twice. Shift 2 seconds. Or e to the 2 tau d tau. And 3, then that will be 0. That's all. Right? So that means here, what is this limit? What is this limit here? You look at this. When t equals 0, that's negative 3. When t equals 1, that is negative 3 plus 1. When t equals 2, that's negative 3 plus 2. How about when t equals negative 1? This integration from negative infinity to negative 4, right? Right, negative 4 means negative 3 minus 1. Right? So can you generalize what this is? For t, for any time.
T minus 3.
T
Or would it be plus 3? Minus 3 plus 3.
This is t.
Minus 3 plus t.
Minus 3 plus t, right? So that will be negative 3 plus t. See? When t equals 1, you plus 1. When t equals 2, you plus 2. When t equals 0, you plus 0. When t equals negative 1, you minus negative, you plus negative 1. Does that make sense? That is the tricky part. Everybody clear on that? I didn't hear you. Yes? Good, right? All right. You can do the integration, right? You don't need me to help with this one. You only need me to help to determine this upper limit and the lower limit. Right? Then the next one is how about the t is greater than 3? T greater than 3, for example, t equals 4. That means this one will be at this point. And this one, t, this one here equals 1 corresponding to tau, but this gives us t equals 4. T equals 5, 6, or this. Multiply this with this one, what do we have? We only have this part. That's it, because we don't have anything to the right. The conclusion is if t is greater than 3, the only overlapped is this part. No matter your t equals 4, equals 400, equals t 4000, everything is the same. Does it make sense? Because we don't have anything to the right. So that means when t is greater than 3, the yt will be equal to, again, this part is the same, 2 tau d tau. What is the lower limit? The integration is from all the way to the left, so it's negative infinity. To where?
-3 plus 4.
Negative 3 plus 4. Plus 4 means, negative 3 plus 4 means 1. You are going to integrate up to this point. Do you need to do integration in this part?
So it's from negative infinity to 0.
So it's always 0, right? Yes? Yes or no? Because no matter t equals 4, equals 5, 6, 7, 8, you use this this one is your window here, right? This window t equals 3, t equals 3.1, all this. Once t is greater than 3, you always like this, but you multiply this with this one. All this part equals to 0. We don't need to care. The only non-zero part is before this one. So the integration is always from negative infinity to here. You can see to 4, but this one equals 0. Also, you can see 5, 6, 7, but that's nothing. The result will be from negative infinity to 0. Yes or no? Still more time? Need more time to think about this? So that's it. That will be our result. You evaluate the integral, then you can plot the result. Who did this correct before this? No one? Half 50%? No one, you have 50%? You have 50%, you have 50%, no? So any further question on it? You can see the tricky part or the most difficult, most important part is determine the integrand. In this case, it's very simple because that is ut, right? And the lower and upper limit. Here, the lower limit is trivial because all the way to the left, so you don't need to think. The only part here we need to determine is the the upper limit. And you need to do this integration segment by segment, right? And in this example, we need only 2 segments, 2 times. So one is this, another one is this. Yes?
how do I sketch? How do I graph this?
Okay, to get this, you need to calculate this one. What's this? This one equals half e to the 2 tau, right? And from negative infinity to t minus 3, so this one will be equal to e to the 2t minus 3 then over 2. This part equal to 0. So that is the result for this one. And this part will be equal to half e to the 2t equals 0, so equals 1. So that equals half. Good? So before that, it will be equals this one. Right? So the plot will be, this is t, this is your output, yt. Right? Before t equals 3, so 1, 2, 3 here, it is this one. What? Okay, after t equals, this one is just constant half. Right? So this one equals half here. After 3, that is easy, right? Just constant. Before that, for example, when t, let me think that is, yeah, right. When t equal to 3, this one equals 0, so it's half. So when t equals 3, that is here, right? How about when t equals 0? When t equal to 0, this is negative 6, e to the negative 6, e to the negative 6. What is it? Very close to 0, right? Yes or no? E to the negative 6. E to the negative 6, very close to 0, right? So this one will be 6, 0, then divide by 2, so it's still 0. So the result will be look like this. And when t equals negative infinity, right, that will be equal to 0. Only equals 0 when t equals negative infinity. So the output looks like this. Anyone get this correct? Close? There are examples in the textbook. You can try more. Or there are examples on the website. There are a lot. So YouTube, because this one is very important, very tricky problem. You can find a lot of examples, lectures, tutorials on YouTube to help you how to do this convolution. So no matter what, you need to know how to do it. If you still have questions, you can ask. You can discuss with your friend, you can look online. And we have examples in the textbook. Also, we have examples in the slide. Any further questions? No more? Everybody is good? Everybody is bad? No response? What does that mean? Hello?
Number 3 was the hardest one.
Huh?
Number 3 was the hardest one.
Yeah, number 3, yeah. This continuous time convolution, as I said, is difficult. If you want to go to the graduate school, they want to test you. So in signal systems, if there's one question, that's this one. Convolution. The most fundamental. So can I assume you are okay with this? Not yet? A little bit?
Maybe some YouTube in the future.
80%, 90%? How you evaluate yourself? 70%? 80?
The square root of 5.
Square root of 5. Square root of 5. Oh, that is a lot. That is 2.236. Huh? 2.236. More than 100%. Right. Any other question?
So the test gonna be like, open notes.
Yeah, I think open notes or not. What's the difference? do you need different? Do you think it's any different? I think the only open notes only hurt you. You need to try to find something in the notes, but actually nothing. Right? You still need to do this by yourself. Right? So open notes or not? Who cares? Okay. I know you still need more practice, right? So practice by yourself. If you still have questions, struggling on this, you can discuss with your friend. Still need more, then we can discuss. Right? Yesterday, some of you come to my office. Actually, how many? Three? Right? 3 of you. Right? Different times. And I'm happy to solve this. So now, this solved to everybody. I will help only if you want to study. Yes? I cannot force you, right? So if you come to me, then I will help you. Okay, today we are going to discuss still convolution, but in discrete time system. Right? Before you open any note or anything, can you still remember the formula for discrete time convolution? We mentioned this at the last minute, last time.
It's sigma.
Sigma, okay, perfect.
Sigma something.
So y, now this is the n, right? Equals sigma, that's corresponding to in continuous time the integration. Sigma for all k, negative infinity to positive infinity. What is it? You just consider this one continuous. That's very similar. Anyone? You may need the open notes for this part, but I ask you to memorize this. So what is it? X, K, right? Like in the continuous, that is tau. Then times H, A minus K, perfect. That's it. Okay, now, without looking at any notes, I want somebody to tell me the procedure how to do this by looking at this formula. Step 1, step 2, step 3, then the result. I'll give you 2 sequences. How are you going to do the convolution in discrete time? Who want to try? Step 1. Anyone? It's very similar to continuous time. I believe you said you are okay with it. You get 70 points, right? So you know the formula. Okay, first line is, step 1 is we need to draw this. How to draw this? We are given xn, right? So you just copy xn, but change the n into a k, like change the t-axis into tau. So that's no big deal for this one. Question on it? Now this is a hint. Now the second step. I want somebody. You flip, right? So you flip, that means you flip the other one, right? Because we keep this one here. So you flip the other one. So how you get to flip the other one? The other one means you draw H, you flip means H negative K, right? That's the only flip. Right? So this is called flip. Good? Then the next one is shift. That gives us a shift by n time. So that gives us n minus k. Shift this one, we get n minus k. The next one. Look at the formula. The next one we need to calculate xk times hn minus k. We find the product for each k. What's the last one? Summarize. Sum up all this product. Right, that's it. Can you do it? That's easy, right? Okay, let's try. Right?
That XN and HN?
X and HN, yes.
What use?
Okay, now try to find the, what is this? Again, this HN is the impulse response, XN is the input, right? And we know this one, YN equals XN convolute with HN. So I need you to evaluate the convolution. So everybody get a piece of paper and do it. Follow the steps on the left. You need to practice by yourself to be able to do it, right? So let's change this one a little bit. Change this to 6. Otherwise, too trivial, right? Okay, step 1, plot xk. Everybody. Okay, what? Correct. Anyway, I want to do this on the board. You want to try? No? If you try, I'll give you half point. No? You give out a half point. Who wants the point? Who wants the bonus point? You want it? Okay, go on there. What's the difference? Right? You do here or you do there? No difference, right?
It's gonna be a huge L.
Plot xk. We know how to plot the signal, right? At the very beginning. What happened here? What's your result? How much time did you spend on reviewing the lecture notes? That's UN minus UN minus 3, right? First time you draw UN, then you draw UN minus 3, then you subtract these two. And when I finish, draw x cap. Okay, good. We have one. Then you can go, you do the second step. Right? You draw HK, then reverse, flip. Okay, let me draw this one first. Draw UN first. Right? Everybody draw UN. You do the second. H. Everybody draw UN. Show me. I count to 3. Right? Draw UN and show me your result. Right? The test will be closed book. Right? So you don't need to looking for anything, you know, right? UN, what is UN? Where is UN? That is the impulse, this is delta. UN is unit step, right?
Oh, we're in discrete time.
Okay, how about this? If you finish, you let me see, then you go next time. Alright? If you cannot, then you just stay here for as long as you need. This is a surprise, right? You cannot draw UN, right? What happened? Yeah, unit step.
I thought discrete time was just a straight up and down line with a dot.
That is the impulse.
Then
Only occurred when n equals 0. Unit step means when n is greater than 0 is always equal to 1. That is continuous time. We don't have continuous time. We have n. N is equal to 0, 1, 2, 3, 4. All these integers. Okay, good. Now you do edge. You do shift. Okay, good. Do the shift. Okay, let me give you a hint of UN. Yeah. Anyone? Before? Right. Go on. This is N. That is UN. This amplitude equals 1. So when n is greater or equal to 0, the value equals 1. That is UN. Now you draw UN minus 3. Then you subtract these two. That is xn. And then you change that n into a k, you get xk. Who has reviewed the lecture notes or the textbook? Anyone? Okay, 1, 2, 3. Did you review the lecture notes and the textbook?
You talking about like
After the class, I mean.
all of like homework.
Only the homework. 12 hours is full time. Right? Full time is 40 hours. The dean always said, okay, for each hour you spend in class, you need to spend 3 hours out of the class. So expect 3 or at least 3 hours. This is 3 hours you need. For each week, you need to spend 9 hours in the class for this class. Okay, that's good. Then you continue to do the second step. H, K, then you flip. You get H negative K. This one? Okay, good. Now, that means n equal to 0, right? Without shift, that means n equals 0. So you just multiply these two, then you add up together, that gives us the output when n equals to 0. So can you tell me what is the output when n equals 0? You multiply, you add before you shift. This one and this. What's this? Nothing. This one, this one. So what is the sum? 0. So that means the output when n equals to 0 equals to 0. And now you need to shift. How to shift to the left? Negative time. You need to shift this one to the left. Then you multiply. What do you get? 0. Okay, now you need to go 1. For example, when n equals to 1, you shift this one only to the right by 1 time. So this one is here, this one will be here. So then what do you get? Then you do this all for all time, you get the output for every time. Which one? This one is U, that's UN, right? UN minus 3 means you need to delete this by 3 times. So this 3 times means this one start from here like this one, right? Because this is UN, this is UN, this is UN, minus 3. You delete this one to the right by 3 times. So this one here will be here. This one will be here. This one will be here. Okay, then now this one minus this. What do you get? So you still have this one here, right? And this one minus this. This sequence minus this sequence. Huh? What do you mean? This sequence minus this sequence. This one is xk, xk.
UN minus 3.
Where's the un?
Well, I didn't do it all out. UN would be just this, right?
Okay.
Continuous, right?
And un minus 3.
Would just be that continuous, right?
You shift it to the wrong direction. Un minus 3 means to the right, right?
I would just have these.
You only have that?
Well, yeah, UN is just this continuous. UN minus 3 is that.
Where is un minus 3? Start from where?
Starts from 3.
Okay, then what's your result? Yeah, this one is gone. So how many you have?
Just 2.
2?
3.
3. Okay, good. Now that is xn, right?
Okay.
Then you change this n to k, that gives you xk. So that is step 1. Now you do hk, then you reverse, then that gives you n equal to 0. You multiply, you sum.
So now we gotta.
You draw hk, same thing like xk. So first one, there's no integral. You need to use summation. So don't write this integral, right? Because this is discrete time. You only use that sequencing, right? So this is xk. This one equals hk. Then this is xk. Factor is from 6. Okay, good. Then less than 4. 4. Okay. Now be careful. Equal. When this one equal to 4, where is this? This one will be at 0, right? Because this is negative 4. Equal to 4, this one will be 0. 0, and this is 0.
Yeah.
So that means 1, 1. So you are going to have a value.
Oh, okay.
Right?
Less than 4.
Less than 4. Or less than or equal to 3. Is that? Cannot be 4. 4, you are going to have 1 value.
Okay, yeah. How about the other part?
Our part, less than 4 equals to 0. Now, for example, what is when n equals to 4? What do you have?
1.
1. Right? How about when n equals to 2?
1.
You have this slit, okay? So like this one. This is xk. This one is right? Hk. So when n equals 3, you are going to add this point. It's 3, so you have nothing, right? 4, you like this one. Right? So you have 1, right? When n equals 2,
Oh, yeah.
3, 4, 5. Anyone? Need help or you have progress? Let me know. Raise your hand. Okay? Okay? What is this? Okay. Unit step is from 0 all the way to this one from 3. This signal minus this signal. So when n equals to 0, what do you have? This is 1. This is nothing. This one is very so here, yes, perfect. 0, so you're going to get 1 here, right? And when 2, when you have 1, this one is still 1, right? Because you have value here, but you have nothing here. Then 2, So this,
That's
yeah, that is R.
That's what I'm told.
Alright? So that's okay.
And then second part.
And this is the XA, right? You change A into K, that's a QA K. Now next one to the HK. They reverse, they shift, they multiply, they sum. Everybody help, right? If you want my help, that's okay. Otherwise, you can help with the other, right? Everybody gets XK?
On the right side, it has some.
Yes, that is HK. And now you need to find H negative. Where is the XN? UN is factor 6, right? Start from 0 all the way to the right. UN minus 3, you start from 3 all the way to the right. Right? You need to start from 3. Wait, start from 3.
Well, we started minus 3. We will start at 3.
Right? So this is UN minus 3. This one is UN. This one minus this, corresponding to the
it's basically yeah, that's
how many? How many spikes? How about when A equals 0? So you have 3, right? So for 0, 1, and 2. All others kind of this is 3, you have 1, but this one also has 3. You only have 0, 1, 2. So you have this 3 non-zero value. That is XK, right?
So once we check non-zero value,
Okay, when N equals 4, before 4, nothing, right? Okay, good. When N equals 4, so what should we do from when N equals 4, what is 0 to 0?
okay.
When N equals 4, you should do this like here,
I know. That's why
and here, right? Then you will multiply, then add what you get. 1, that's the output of the N equals 4. Then when N equals 5, this shift this one to the right, it will here and here, right? So you multiply, then you add, you get 2. Then when N equals 5, just slide, multiply, and add. Finally, sometime you get you mean the output? So you already know that's much. For N equals 4, that will be equals y4, right? Equals 1 times 1, right? There's only one value. When A equals 5, you are going to 5. This value equals 1 times 1 plus 1 times 1, right? Equals 2. When A equals 6, so now you need to 6, or this one will be 4 plus 6, and you from here over here, right? So equals 4. 0 here. This y6 still in this one, right? Yes, 7 is y, it will be here and here, right? That one equals 1. And A equals 8, 0, then greater than 8, then just y at N equals. So the result will be, this one is lower. If you want plot, N equals 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, what is N equals 4, then equals 9, 5, 4, 7, 1, nothing. And all nothing. So this is, yeah, this one is the output.
So again, are you in?
It's like,
If you already get it correct, then you help others, alright? So
yes, sir, you see, mostly.
everybody needs to know how to do this. Flip means it is here like this in this side, then you just flip. Mirror with the y-axis.
Oh, I see. So, run code at PLC.
You want to flip this or you want to flip that? You flip only one.
I was thinking.
H. So you go HK first. Do you have HK? Yeah, go HK first. You have that. Oh, this one is XK, right? This is XK. No, this is X. This is H. H is what? U n minus 4 minus 6 minus 6. 4, 6.
That's what I was confused about.
Four, U n minus 4 means start on 4.
Which means it is 80 and 4 negative 5.
Yes, there's no difference.
So it doesn't matter. Like if you go up to like negative 5. Like if you like negative 5.9.
Negative 5.9. This only just integral. There's no 5.9. There's only 1, 2, 3, 4. There's no 1.5.
Alright, so it is just negative 5 here and negative 1.
Yes. Because there's no difference. But this one is cancelled by I don't think we need to do 1 by 1. 7 because you can still when A equals 4. When A equals 4. Again, you don't want you need to find this 1. So for this one here,
Appreciate it.
This is X. And N equals 4.
So then, your original. When you're at this point here, so T0 is going to be starting there. Do the same. Go T1 is going to be negative 3. Whereas I'm going to yeah, you don't leave there. You compare it with that. Gas line. That is the under each other. It'd be 5 on that. There's no 5, so that'd be 0. All the way negative right here. Where there's any values on that.
Started 6 years. Yeah, 3 6 on you though. Everything, all the one we had.
So it starts here. If you shift this one to the right one, and you compare it with that one's going to be going, yet you're shifting those two signals, the 2 lines there to the right. Then you compare this up here, there's nothing. So it's 0. That's going to be the same all the way to 10 plus the 4. That 4 right here. That one is going to line up with that one. That's going to be 1 times 4. That will go 5 4 is 1. That is what you would do as your answer.
Okay, we have somebody have
Shift it to the right.
Yeah, good, right?
To n equals 5. It's going to line up. both of these. With that. So 1 times 1 is 1 times 1 is 1.
Okay.
Add those together, you get 2. So we're going to plot it as 2. You just keep shifting all the way.
What is this
3,
one?
it's going to be lined up.
This one is U4, UM minus 4 is
Same thing, 1 times 1,
0, 1,
1, add them together.
yeah, one minute. You
Shift it again.
this U4 means
Get rid of that.
here,
Here
5,
and there.
6,
1 times 1.
7, all the way to the
0,
right,
0.
right? Yeah? Now the UM
At that point on,
means start with
if you're above,
yeah, this one minus this, so you have only
greater than 8,
you're
shifting
Yes.
greater than 8.
This one is X. The next one you need to flip this one. Okay, so you get X negative K. Yes, perfect, yeah. Yeah, this is a flip, yeah. Yeah, okay. So you flip. You haven't shifted yet. That means A equals 0, right? That does make sense? So you are just flipped, you haven't shifted yet, that means A equals 0.
It helps. If you just do the correct way.
No, first one you just calculate A equals 0, that's your output. What is the Y 0? You flip, then you just multiply, then you add. Negative. Huh? So what your X is that's why you are employee, that's simply 0, it's 1, it's 2. That's it, right? That is your X. And your H negative K is this. And that means
Value in.
A equals 0. So we haven't shifted yet. This one times this. And you add up
You
together.
don't have to
What do you
line
get?
all down right there, but it's less than 4 is equal to 0.
Okay, let me draw this. It's
If you repetitive doing that, you're getting the 3 and 0 in greater than or less than 3.
Now this one times this.
So just figuring out where it starts, where the value
This one
changes
is
to
0
1
times 1.
and then it's
What do you get?
less than that.
0 times 1. This one, 0 times this. This one times this. This one times this.
Where any time n is less than 4.
This one times nothing here. So all the product
Or would be shifting it.
equal to 0. You add up together, you get 0. Right? That means we don't have any output time.
The shifts are n minus k.
You group
Your
up.
k is just
Okay, now the next one is how about the n equals negative 1.
so n minus k.
Next one is you shift this one to the left by 1 time, right? So this one will be here, this one will be here, this one will be here. Then you multiply and 0, 0. How about equals to n equals 1? You shift this one to the right by 1. So this one will be at here and here, right? From 5, 4 to 4, 3.
I could be wrong about that. No, but I didn't know anything about it. Visual.
Yeah.
So we write it in less than 4 and then just make it what it is.
Yeah, that is what we should do. This one here, just explain, right? So when n equals 1, you get nothing, right? When n equals 2, you get nothing. When n equals 3, you get nothing, right?
Negative 1.
Okay, 4, now 4 is what we have right here, right?
0 starts at 4.
Yes, so what you get is 1, right? How about the n equals 5?
So the shifted
You get
1
2, how
goes
we get
negative 3.
this one will be, so the result will be right here, right? Multiply, that will be 1. This one will be 1. 1 plus 1. How about the way? This equals 6. 6, this one will be here.
Yeah, you can
This
do
one will be here. This will be to here. This one will shift to here. And this one times this equals 1. This one times this equals 1. So the result is good, right? The next one is n equals 7.
At
And this one will be here,
n is 0
here, right? This one will be here,
The first one would
You get
have
only
been
this.
at
This not
negative
this,
1
not
still.
this. You get
The
the
second
one.
one that was originally here
Y7
would be at 0.
equals 1.
So it would be 1 times
Therefore,
4.
n equals 8.
So it gives you
Y8,
1.
yn equals 0.
So at n equals 4, your output is 1.
So this is plot. The result equal to nothing.
Okay. And then times
1
1.
times 1.
So yeah, the result that is even more.
1 plus 1.
Make sense? So how can you plot the output?
The next one.
The output when you draw this one, n 0, 1, 2, 3, 4,
And then everything after that would be
6,
0.
7,
Closer
8,
to n greater than,
So can
n
you draw the
greater than
output?
8, but it would technically be greater than.
As for the before 3, you get nothing.
Then at 4, you get over.
4, you get 1. 5, you get 2. 6, you get 2. 7, you get 1. And all output.
He worked there. He worked there. He worked there. You moved it to 5. You got it here. So it's what, like, you one, it's 2.
Okay.
Or 6.
Oh, it's just graph. No, really. Negative 5.
Yes, 1 times 1 is 1. 1 times 1 is 1. Yeah, 2.
Negative 5 would be. These numbers here are, of course, how far you're shifting. So if you wanted to, this is the original
Where? Get
set.
it?
You're doing n minus, that's what you're shifting. This is the value of n, is what these are.
Are you gonna finish it on the board? Are you gonna finish it on the board?
Negative 1 would be
Homework?
shifting
This.
and this on the left.
I mean, I'm scared.
So it would be on negative 6,
So everybody,
it would do a left shift.
He's out there 1 and 2.
Don't say that.
Because if you take n minus negative 4.
Oh, yeah. That is it.
okay. Looks like everybody is happy, right? Everybody get understand everything? Before I make a complete solution here, so you can see what we have. So everybody understand? It's good? Okay, now let me do this. First one, I draw UN. Start from here to this one. Surprise to me, you don't know how to draw UN. That's not. Don't do this again, right? This is UN all here. Then UN minus 3 start from here, 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 all the way to the right, right? We need to subtract these two, so definitely just like this one. That is what we have left. That is xn. So that is x. That is xn. And this one here is n. But what we want is k. So that's easy. You just change this n to k, change this n to k. Nothing fancy here. Make sense? This is xk. Okay, next one is we need to draw hk. Same method. U4 start from 4. 4, 5, 6, all this to the right. So start from 4, 5, 6 to the right. UN minus 6 start from 6 all the way to the right. So start from here, 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 all the way to the right. We subtract these two. What we have left is only these two. You must be very careful. Sometimes somebody forget this point. Somebody, okay, give me this point. All are incorrect. You need to be careful. So this one is only have 2 values. This one has 3 values. So just like this. This is called HN, but I will change this one to a K, so that's going to be HK. Question? HK, I need to reverse one, right? So I can reverse this, or I can reverse this. It looks like I want to reverse this one. So I will make a negative K here. Then we need to do the reverse. This one equals 0 here, right? This 4 will go to a negative 4. This 5 will go to negative 5, and we have these 2 values here. Now these 2 are gone. We don't care anymore. This is h negative k. That's step 2. We flip. Before we shift, that means we shift to 0. Right? So if I plot something here, okay, I can put 0 here. Doesn't change anything, right? I didn't shift yet, so that means the shift is n. So this n equals 0. Now I will calculate the output. So output when n equal to 0, yn, I can write y0. Or you can just write yn. Same thing. When n equal to 0, we need to calculate the output, which is sum up all the product of this and this. That means this and this. And multiply for each k. This k, this k, this k, this k, this k, this k. For all k, you multiply correspondingly. Then you sum up for all this product. Right? Now let's see. Before this, we have nothing. You multiply nothing. This one, or nothing. Right? So for this one, for 1 times 0, this one gives us 0. This times this gives us 0. This times this gives us 0. And nothing here. This 0 times 1 gives 0, 0, 0. So you can see we have only 5 products. All of them are 0. This one gives us 0. Make sense? So that is the first step. Okay, I do not shift yet. I haven't shifted yet, but this gives us n equal to 0. Now I need to go both ways. I imagine I shift to the left. That means n equal to negative 1. Actually, when you really do this, you don't need to. This is just help you how to think. Right? So n equals negative 1, that means I need to shift this one to the left by 1 time. So this one will be here, and this one will be here. Negative 5, negative 6. Right? Forget this, it will be like this. So this one will be, this equals h negative 1 minus k. Negative 1 minus k. Corresponding to when n equals negative 1. You multiply, obvious, still get nothing, right? This is 0. So you can imagine for every n less than 0, you get nothing. So I can change this one to less than 0. I don't care all this. I already know nothing happened here. Does it make sense to you? Oh, that's one. Now let's see. When n equals 1, that means I need to shift this thing to here, to the right by 1 time. Okay. So this one will be here. This one will be here. This is h1 minus k. Okay. Now you forget about this thing, right? You forget about this. So I will write this one negative 4, negative 3. And this one is gone. Right? Now multiply, add, what do we get? Still 0, right? So still 0. Okay, we can consider this. This is n minus n equals 1. How about n equals 2? N equals 2, it will be negative 3, negative 2. Multiply, still nothing. So that is n equals 2. How about n equals 3? That one will be from here to here. Still nothing. Right? So until n equals 3, so obviously less than or equal to 3, nothing here. Does it make sense? Everybody? Yes? Hello? Everybody understand, right? All right. So the next one is when n equals 4. n equals 4. This one will shift to 0 here. This one will shift to negative 1. We have this two. So this is 4 minus k. Means n equals 4. Multiply. Alright, now be careful. This one still nothing, but this one 1, 1. 1 times 1 equals 1. And this one here still nothing, nothing. So we have only 1 non-zero value, so which is 1. So that's 4 equals 1. Questions? The next one will be n equals 5. And give us the output when n equals 5. So we continue shift this one to the right by one more. So this one will be here. This one will be here. So it's from 0 and 1. Now you multiply. You add. What do we have? 2. Everybody get 2? Right, so that's 1 equals 2. N equals 6. Give us output y6. I continue shift this one to the right by one time. So this one will be here, and this one will be here. So 1 and 2. Right? You multiply. What do we have here? Nothing, because this one not here anymore. This one, 1. This one, 1. We add. What do we have? Still 2. Right? Then the next one, n equals 7. So give us the output when 7 equals, this one will be to here, and this one will be here, so like this, so 3. That give us, this one here is 7. Flip, shift to the right by 7 seconds, that give us this one. Now you multiply this one, others you don't need to consider because all zeros. This one, nothing. This one, nothing. This one here, 1. This one, nothing. So the result will be equal to only 1. Okay? We shift even more. N equals 8. This one will change to 3, and this one will change to 4. What do we have? 0. And yn equal to 0. How about the 9? How about the 10? Right? Greater than 8, greater or equal to 8, you get nothing. These are the output. That is what I want from you. If I ask you to plot this output, what the output look like? This one is n. The output is a function of time. So this is yn here. And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, all this. So the output plot will be, before 3, you get nothing. You need to mark clearly with this circle or dot on this one, means this one equals 0. When n equals 4, this gives us 1. You need to mark this one equals 1. When n equals 5, that equals 2. When n equals 6, that equals 2. When n equals 7, this is 1. And all others equal to 0. Does that make sense? That is the complete solution. Okay, now when you do projects later time, right, so you may want to implement with a hardware of this convolution. You need to have storage, right? So now we need to consider how much storage do you need. Suppose the length of this xk equals m1. The length of this one equals m2. And here this m1 equals, how long is this duration? 1, 2, 3. So equals 3. Does it make sense? You have 3 numbers here. And this one give how many numbers do we have? 2. Now, how long is your output sequence? Look at here. 4. Right? How do we get a 4? 3 plus 2 minus 1. Right? So in general, the length of this one will be m1 plus m2 minus 1. So by this way, when you buy the equipment hardware you want to implement this, you need to know what is the length of the first signal, what's the length of the second signal. Then this add together minus 1, that is the length you need to store for all the output. How about the others? Others all equal 0, so you don't need that storage.
That make sense? Let me give you this one here, right? About the length of this one. How about like this? 3, this is 4. How long is this signal?
That's 5. And then there's,
Four.
what's 4?
4 or 5?
I don't say 5 because you have a space there. A single link is 5.
So 4 or 5? Which one? Some says 4, some says 5.
Four.
Now you imagine when you flip this one, you slide, you calculate. So is this a 4 or is this a 5?
It's a 5.
I'll give you more things. Like this one. Right? Here, or nothing, but there's one here. This one equals 100, very far away. Now you flip, you slide. How long do you think your output will be? You think this is only 2? This is from 0 to 100. How long is this sequence? 101, right? You need to consider the numbers, the zeros in between. So in our example, if like this, that M1 equals not 4, 1, 2, 3, 4, not 4. We need to count this one, so equals 5. Means from the first non-zero value to the last non-zero value, anything in between is counted. You need to stop it, even if it's 0. Okay? Any other questions? All right. Now we have this one is lengthy, right? Not easy, right? We have a better way to do this. All right. I will mention this and ask you to read the lecture notes. Right. We already know this one equals UN, the xn is, can I write like this? You already plotted xn, right?
Yeah, these are all good.
Is this correct?
It is.
We use fundamental signals to represent a signal. Is this correct? Yes. Okay. I want you to say yes. If not, you read the lecture notes. What is Hn? If you said yes, then you should be able to write. What is here? M plus n minus 4, right? Plus n plus n minus 5. That means the value equals 1 when n equals 4. Equals 1 when n equals 5. That gives us 2 spot. Alright, now the interesting part, right? Xn convolute with Hn means this one convolute with this. That's for sure, right? Ask you a property. What is Xn convolute with impulse n? What is this? Right? Let me give you a hint. The convolution, what does the convolution mean? Convolution means this is, for example, this is the signal. This one is the impulse response of the system. So you pass this input to the system, you get an output here. That is the physical meaning for this convolution, right? If this one is the impulse response of the system, this is the input. You do the convolution, that means that is the output. Right? Right. If a system, its impulse response is impulse n, what system is this?
Street.
That's a street. Okay, we mentioned this last time, right? Because the meaning means if your input is impulse, then the output impulse. That is called impulse response. So if the impulse response is this one, means this is a straight line or path filter. So what's this one convolute with this? X convolute with impulse equals what? This one is a straight line. You have xn here,
You have this one here, you have YN. And this one is a straight line. What do you have here? XN. The output equals the input. So that one equals. So any signal convolute with the impulse equals itself. That's the physical meaning here, because this one means a straight line, you already mentioned. So input is X, the output must be still X. Good? How about this one? Minus 1.
It would just be X and minus, right?
Yes, okay. X minus, what does that mean? This means this is an ideal delay, just delay by 1 second. So you have a signal here, you delay by 1 second, what you get is X n minus 1. That make sense? Okay, so now let's see this. This one convolute with this, n minus 5. So what I have is, I copy all this, n minus 1 plus n minus 2. All this convolute with n minus 4 and plus n minus 5. So we have 3 terms here, 2 terms here. Convolute, so we are going to have 6 terms. Right? So the first term is this one convolute with this. This one convolute with this. What do you have? This one, right? Because this is impulse. Impulse convolute with anything, you still get that thing. Make sense? Impulse convolute with xn, you get xn. So this one gives us this one. And this one convolute with this, you still get this one, right? So we get still this one. Right? We're done with this one. The next one is this convolute with all these 2. What does that mean? Ideal delay by 1 second. So this one convolute with this. That means we just delay this by 1 second. n minus 4. Delay another second. What do we have? n minus 5. So this one gives us n minus 5. How about this one? n minus 6. Okay? Plus n minus 6. Alright, we done this term. Now this term. This one means delay by 2 seconds. This one convolute with this one, so what we have is n minus 6. So we get n minus 6. And this one here, n minus 7. Are we done? Yes, we're done, right? We have only 6 terms. 1, 2, 3, 4, 5, 6. Then add all this together. Now, in your head, you imagine what we are going to have. When n equals 4, we have 1 value. So that one is 1 here. When n equals 5, we have 1 here. So we are going to have 2 values like this, right? When n equals 6, we are going to have 2 also, like this. When n equals 7, we are going to have 1 here. How about the others? Nothing. Output is 1, 2, 2, 1. When n equals 4, 5, 6, 7. Is this the same as others? This one give you theory. This one give you need to use the engineering, right? Technology. We need to understand the physics behind this. We do not want only do the math. You need to know what does that mean. This impulse mean. Impulse you already mentioned. That means straight line. What is the impulse n minus 1? Means ideal delay by 1 second. So if you give me a xn past this one, what I get is xn minus 1. Use this idea so we can quickly use this. Make sense? And we have a complete discussion of this in the slide. Right? So you read the slide and discuss with your friend. I like you discuss. Okay, you discuss a lot, so I hope it will help. Help, right? Okay, thanks.